Hello and welcome to another online learning day, another topic of chemistry. Our essential question that we're going to be going through today as we continue to understand more about the language of chemistry in the form of sentences, which we call equations in chemistry. We're going to learn about something called the law of conservation and balancing chemical equations. So the two essential questions today are: what is the law of conservation and how do I balance chemical equations? Before we get into that, though, I want to do a quick review from writing chemical equations that we learned about the other day. So, what I'm going to do is I'm going to give you a chemical reaction described, and we're going to write the symbols for it. So, let's practice this. So, imagine we had this reaction that happens: solid calcium, when mixed with liquid water, will produce solid calcium hydroxide and hydrogen gas. Now, remember, one place to start is just by putting down an arrow. We know that we're going to start with something, there's going to be an arrow, and we're going to end with something. And then we're just going to take it in little pieces to figure out what goes on the left of the arrow, the reactants, what goes on the right. Now it says will produce these things. So I know that the first word, solid calcium, is going to be something I start with. Calcium is an element, which means we got to check to see if it's a diatomic element. Brother Honcliffe. Nope, there's no calcium in there because the symbol for calcium is Ca, not Cl. So that Cl is not calcium. So just Ca, and then we put the little S in the parentheses. Remember, those parentheses matter to say solid calcium. It says it's mixed with, which really just means and. So we're mixing it with something else. The plus sign says these two things are not already combined. Liquid, water. Water is one of those formulas we just know is H2O because the common name is water. The actual name is dihydrogen monoxide, which is why it's H2O. And then we want liquid, the little L in parentheses. We already have the will produce, that's our arrow, and then it says solid calcium hydroxide. Now, this doesn't have anything in between it, so that means that this is a compound. Calcium is a metal, so we need to look up the symbol in charge of calcium, Ca with a +2. Hydroxide is on our ion guide sheet, so OH -1. Because calcium is a +2, it's trying to give away 2 electrons. But hydroxide can only take 1. So we need another hydroxide to balance that out, put parentheses around it, a 2 on the outside. Calcium hydroxide, 2 OHs to balance out that Ca. It says it was solid, so we put that little S in the parentheses. Then there's that little word and, so don't forget your plus sign, hydrogen gas. Hydrogen is an element, the symbol is H, but we got to check if it's a diatomic. Brother Honcliffe, yep, H. H is hydrogen, so H2 and then the little G there. All right, that was what we learned how to do last time, taking a full sentence with words and putting everything into symbols. Oh, we should double check. Does it say anything special about the arrow, catalyst, or heat? Nope, it doesn't, so that's why we can just leave the arrow blank. But what we need to add today is, well, wait a second. I've got 2 hydrogens here, but I've got hydrogens in 2 separate places. 1, 2, 3, 4. Something isn't right here. That's not allowed. I have 1 oxygen here and suddenly 2 oxygens on this side. That doesn't seem like that's allowed. So that's where today's topic comes. So the point of today is to do something called balancing equations. So what you're going to do today are finish these video notes, and then there is a balancing equations assignment you can start. And then on January 14th, both of our equations assignment, the balancing equations and the writing equations, we're going to use as practice day for help. So just know that the important thing is to get the notes done and start the assignments so you can come to our January 14th class and get some help. All right, so go ahead and set up your focus notes today. The topic is balancing equations. Fill in the date that you're taking these notes. And these are the 2 essential questions. What is the law of conservation? And how do I balance chemical equations? Set up those focus notes so you've got a place for your notes, your COSTA questions, your summary, and go ahead and pause the video if you need more time. Otherwise, let's get into it. So when we look at equations, that word equation means that it's supposed to be equal. But look at here. I've got 1, 2, 3, 4 atoms on this side and 1, 2, 3, 4, 5 atoms on this side. That doesn't seem allowed. I have 1, 2, 3, 4 atoms on this side and 1, 2, 3 atoms on this side. Wait a second. So for all of these, there's a problem with balance. And the reason that's a problem is because of this thing called the law of conservation of matter. Remember, you only have to write down the stuff in red. So the law of conservation of matter says this: matter, the stuff that we're using in a reaction, cannot be created or destroyed. in a chemical reaction, but the particles can combine, separate, or rearrange. So if we think back to those equations that I just showed you, that's what happened. Sometimes the particles disconnected, that's separate. Sometimes they made new connections, that's combine. Or sometimes they just kind of switched around their order, that's rearrange. That's fine. But you can't suddenly have more atoms at the end than you started at the beginning. That's the problem. That's the problem we're going to learn how to fix today. So, this is the definition of the law of conservation of matter. So, when we think of matter being made of particles, we think of particles that are made of atoms, and we have a particle atom equation like this. It looks like matter was created because look at I have 1, 2, 3, 4 atoms on this side, and then 1, 2, 3 plus 4, 5 atoms on this side. That isn't allowed. So we say that this equation is not balanced. We didn't worry about that last time because we were just building our skills. But now, as a chemist, we can't ignore the fact that it looks like matter was created. Go ahead and take your first break, and then we're going to talk about how we fix this. So, a level 1 question comes right from the notes. Maybe a great example would be state the law of conservation. That would be, or define the law of conservation. Either one of those. That would be a great level 1 question. Otherwise, go ahead and pause the video, write your own question, come back when you're ready. Here we go. So let's talk more about that law of the law of conservation and then reactions. So in order to obey the law of conservation, we must have the same number of each kind of atom on both sides of the chemical equation. And what I mean by that is how many reactant particles did we start with? How many reactant products did we end with? Or how many reactant particles did we start with? How many product particles did we end with? They have to be the same number. Now remember, they can switch orders, they can connect with new things, they can disconnect from other things between the reactants and the products. That's allowed. But the total number of atoms needs to be the same. That's how we connect the law of conservation to chemical equations. That's what we're going to learn how to do next. So we look at this. So back to the demo equation, that one with like the foaming tower. So this is hydrogen peroxide produces water and oxygen. We know that that's wrong. We need to add something called coefficients. Those are big numbers we can put in front of a chemical. They multiply to the atoms behind it so that we obey the law of conservation. So look, I put coefficients in front. Now look at this. 2 times 2 H's is 4. 2 times 2 H's is 4. So that's good. 2 times 2 O's is 4. And then look at, I have 2 O's here plus 2 more. That's 4 O's. So now that is a balanced equation. We have the same number of all the atoms on the reactant side, same number of all the atoms on the product side. That's what we're going to learn how to do. So that is called a coefficient that you can put numbers in front. Once you write the formula, like this was hydrogen peroxide, this was water, this was diatomic oxygen, we can't change these numbers because these numbers are specific to chemistry. The numbers in front will be specific to whatever balancing equation we're trying to do. All right, let's learn how to do this. Here are some hints and helps. What I recommend you do is just let me finish this slide, and when I'm done, take a screenshot of it, and then you'll have these hints and helps. So here's how we generally balance an equation. We go from left to right again until everything is balanced. You just kind of go back and forth. After the formula, like for water, H2O, or hydrogen peroxide, H2O2, once those formulas have been written, you can only change the number in front, that coefficient. Because remember, those formulas are specific. We can't change those. But we can put numbers in front that will multiply to change the number of atoms. This is a really nice big hint. If one side is odd and the other side is even, find the odd and double it, meaning times by 2. So if you have 3 atoms on one side and 2 atoms on the other, what you'll do is multiply that 3 times a 2, and then you can go back forth and balance equations, put numbers in front. Sometimes writing water as HOH instead of H2O will help you match up OHs on water and hydroxide on the other. That's a hint. And then remember those things called polyatomic ions, those group atoms. Don't split them apart. So for example, NO3 is nitrate. If you have NO3 on both sides of the arrow, don't think of it as 1 nitrogen and 3 oxygens. Think of it as 1 nitrate. Or if there's parentheses around it and like a 3 on the outside, that's 3 nitrates. Don't worry about splitting it apart. That'll kind of help a little bit. If possible, do all the other atoms before H and O first. And then the last thing you check is the lowest ratio of coefficients. So if you balance and you put a 2, a 2, a 2, and a 4, all of those numbers could be divided by 2. So really you would have 1, 1, 1, and 2. That's what I mean by lowest ratio. Okay, go ahead and take a picture of this slide. Make it be a screenshot. These are good places, just hints and helps when you're first learning how to do this. Some of this I know doesn't make a lot of sense until we start practicing, but go ahead and take a screenshot of this slide so that you've got this as reference, and then you can just put that slide in your notability for this unit. All right, let's try this. The first thing we got to do though before we start balancing is we got to make sure we understand the difference between a coefficient and a subscript. Well, one way you can remember is that a means something that goes with something else. So it's a number in front. It goes with the formula. The subscript, remember sub like a submarine, is something that goes underneath the level of something. So a subscript is that little number that's written below everything else. So if you see something like this, 2 in front, this 2 is going with the formula, coefficient. This 2 is below the normal writing. That's a subscript. So what does that mean in terms of chemistry? The 2 in front of NaCl is a coefficient. It means there are 2 separate formula units of NaCl. This is a formula unit. It's a compound that's bonded out of ions. So formula unit, 2 separates of them. NaCl and a separate NaCl. That's what this means. When you put a 2 at the end of a formula like CaCl2, that 2 only goes with the element right by it, versus the 2 in front goes to everything behind. 2 NaCls, another 2 NaCls. So this means you have 1 Ca and 2 Cls, but they're all bonded together. So one formula unit of Ca, Cl, and Cl. To make sure that this makes sense to you, one of the things I'm going to have you do when you're balancing equations when you're first starting is to draw the particles to show me you understand the chemistry. That connection between seeing the particles and drawing the particles and thinking of the chemistry will help you understand it better once you truly understand it. So for example, this is an NaCl particle. There's an NaCl inside one particle. But then that 2 means there's 2 separate particles, and inside everything is bonded. So the number in front, the coefficient, is how many separate particles you have. The stuff inside is all connected to make one particle. So one particle of NaCl bonded, a separate particle of NaCl bonded. So that means for this, there's no number in front, which means there's only one particle, but inside that particle, there's a Ca and 2 Cls, Ca, Cl, Cl. All one particle connected to each other. That's what makes it a compound, because it's one particle, but it's one particle bonded with different pieces. So numbers in the front are how many separate particles there are. Numbers inside mean what do you put inside that bubble. So that's what I mean by coefficient, number in front, subscript, numbers written down below. All right. Why don't you go ahead and take a little break here? If you need to pause the video, go take a little break, come back in a little bit, but also write your level 2 question. A compare and contrast would be a great example for a level 2. Compare and contrast subscript versus coefficient if you want an example. Otherwise, write your own question. Come back when you're ready. It's time to do some examples. We've talked about law of conservation and coefficients and subscripts and obeying the law of conservation. Now it's time to try it. So let's try this. Go ahead and write this down. Fe plus, leave a space, O2, arrow, leave a space, Fe2O3. So look at, these particles are combining to make one new particle, but they don't have the right number of atoms. It looks like I gained some iron and I gained some oxygen. That's not allowed. So we're going to do trial and error. We go back and forth, left to right, until we have the same number of all the atoms on both sides. Add coefficients in front. Remember, we can't change these numbers in the formula. So I looked and see that I have 1 Fe on this side and 2 on this side. So look, if I put a 2 in front, 2 times Fe balances the 2 Fe's that are over here. Great. But then I look and I see, well, wait a second. I've got 2 oxygens on this side and 3 oxygens on this side. That is that even versus odd hint. So what I'm going to do is I'm going to multiply the part that is odd times 2. That's what doubling it means. So now I've got 2 times 3. That is 6 oxygens now. And so then on this side, I can put a 3 times 2. That is 6 oxygens now. But remember, when you put a number in front, it multiplies to everything behind it. So now I've got 2 times 2 irons. That's really 4 irons. So I got to change that. So then I check to make sure, do I have the lowest ratio? A 4, a 3, and a 2. Can they all be divided by the same number? Nope. There won't be whole numbers anymore. So 4 irons, 2 times 2 is 4 irons. 3 times 2 oxygens on this side, 2 times 3 oxygens on this side. Everything is balanced. We did it. Now, the next piece is, can you draw it? Can you show me that these are not random numbers, but you understand the chemistry? That's the next level that you need to show me as a chemist. This is good for your brain. So a 4 in front means you have 4 separate atoms of Fe. They're all separate from each other. 4 different particles. But the only thing inside the particle is an Fe because this is just an element. Plus, I have 3 separate particles of O2. So inside the particle, there's 2 oxygens. They kind of look like pig noses. Look, OO, another OO, and another OO. So this number in front is how many separate particles do you have? The O2 is what goes inside each particle. O2, 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 but we show them, we write it out. Then I have an arrow, and then I have 2 particles of this, 2 irons and 3 oxygens in one particle 2 times. Fe, Fe, there's your 2 O's and 3 oxygens, OOO. And then another one, that's what this means, a whole separate particle, Fe, Fe, OOO. So not only does this show me that you understand the chemistry, but it also allows you to check your work. Look, 1, 2, 3, 4 irons, 1, 2, 3, 4 irons. Yep, 1, 2, 3, 4, 5, 6 oxygens, 1, 2, 3, 4, 5, 6 oxygens. So you have showed me that it's balanced, it obeys the law of conservation, and it shows me that you understand what is bonded, what is separate, what chemicals are in this compound, and which ones were started with. So that's the purpose of this. Let's try another example, example 2. All right, here we go. Fe parenthesis OH2 parenthesis, or parenthesis 2, plus, leave a space, hi, HI, arrow, leave a space, FeI2, plus, leave a space, HOH. This is really just water, but because I have OHs on the left, I'm going to compare that to the OH on this side instead of thinking of the H's and O's all separate. So we're going to do the same process. Put numbers in front, go back and forth until they're balanced. Let's check it out. I have 1 Fe here, 1 Fe there. Nothing to change. I have 2 oxygens right here because this multiplies in, and I have only 1 oxygen here. So I'm going to put 2 right there. When I do that, though, remember that multiplies to everything behind it. So I've got 2 OHs now. So now I've got 2 OHs here. But then now I've got 2 alone H's and only 1 alone H right here. So I'm going to put a 2 in front. Now I've got 2 alone H's. 2 I's now because I put this 2 in front. Oh, but I already had 2 I's. So then that means I'm balanced. So 1 Fe, 1 Fe, 2 group OHs, 2 group OHs, 2 alone H's, 2 alone H's, 2 I's, 2 I's. We did it. Yay, we're so smart. Let's draw it. So remember, when there's no number written, that means there's just 1. So 1 particle, but inside that particle, I'm going to have an Fe and 2 OHs. So it looks like this. So inside that particle, Fe, OH, OH, plus 2 particles of HI, HI. So inside the particle is HI, hi. And then you've got another one. So the number in front is how many separate particles there are. The stuff behind it, the compound or the atom, is what goes inside that particle. All right, then you have your arrow, 1 particle of FeII, so that's what this particle is showing, plus 2 separate water molecules that I'm going to write as HOH, HOH. So you're showing me you understand the chemistry. It's another level of understanding instead of just kind of the math part of it. Can you also picture what this would look like in terms of particles? That helps your brain connect to it since it's not something we can just see. So 1 particle of FeOHOH plus 2 particles of HI produces 1 particle of FeII plus 2 particles of water. Let's check our work. 1, 2 oxygens. 1, 2 oxygens, 1 Fe, 1 Fe, 1, 2, 3, 4 H's, 1, 2, 3, 4 H's, 1, 2 I's, 1, 2 I's. So that is balanced. It's balanced, it obeys the law of conservation, and it shows the chemistry that happened. Let's try one more example. C2H2 plus, leave a space, O2, arrow, leave a space, CO2, plus, leave a space, H2O. So notice this time I didn't write water as HOH because there's no H on OH on this side. The H's and O's are all separate. So I'm going to think of the H's and O's as separate on this side too. We're going to do that same process, but this is a big hint. We're going to use that odd and even trick. That's going to be super useful in this example. Let's get started. 2 C's right here, but only 1 C right here. So I'm going to put 2 in front. 2 C's now. 2 H's here, 2 H's here. So that's fine. 2 oxygens here, but then now I have 2 times 2, 4 oxygens right here, plus 1 oxygen here. So now I've really got 5 oxygens on this side. Well, there's no way I can make 2 and 5 equal to each other. So I'm going to use that odd even trick. Find where it's odd, double it, and start over. Double means times by 2. So now I've got 2 times 2 H's, which now is 4 H's, and I only have 2 on this side. So I got to put 2 in front. 2 times 2 is 4 H's. But then now I put this 2 in front, which multiplies to the C. 2 times 2 is 4 C's. So I can change this number because I put it here. I need it to be a 4. 4 times 1 is 4 C's. Now let's check our oxygens. I still only have 2 on this side. 4 times 2 is 8 oxygens here, plus 2 oxygens here. That equals 10 oxygens. So what times 2 would give me 10? Blank times 2 equals 10, 5. So I need to put a 5 in this blank. All right, let's check our work because we did a bunch of changing. 2 times 2 is 4 C's. 4 times 1 is 4 C's. That's good. 2 times 2 is 4 H's. 2 times 2, 4 H's. That's good. 5 times 2 is 10 O's. Now let's see what we have on this side. 4 times 2 plus 2 is 10. 4 times 2 is 8. Plus 2 oxygens here also equals 10. Hooray, we did it! So that one took a little bit more work, but it's the same process. Go back and forth, put numbers in front. You can't change numbers in the formula. Now let's see if we can draw it. The number in front is how many particles you have. So 2 separate particles. Inside that particle, there's 2 C's and 2 H's. So I have 2 C's, 2 H's, and then another separate 2 C's, 2 H's. So this is the chemical, the compound. We just have it 2 times. Plus, I have 5 diatomic oxygens. These are those little pig noses. I have OO, diatomic oxygen, 1, 2, 3, 4, 5 separate times. The number in front is how many separate particles there are. Behind it is what goes in that particle. Then we have an arrow, 4 COO, carbon dioxide. 4 separate particles, 1, 2, 3, 4, but inside each particle is COO. COO, 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 plus 2 separate waters. So I have HOH, that's water, 2 separate times. This shows me you understand the chemistry. It's another level of understanding. Not just can you do the math, but do you understand the particles? What is connected? What is used to be connected? What is now connected before and after? So it's another layer of understanding that's helping your brain make a connection between these letters and what do the particle pieces actually look like. That brings us to the end of our notes. Go ahead and do a level 3 kind of question. You could defend or argue or make up your own level 3 question or use that guide for different sentence starters to give me a high quality level 3 question that you can look at later for review. Pause the video if you need to. Otherwise, that brings us to the end of our second day of this unit on chemical equations. Go back and finish any COSTA questions, write your summary for today, and then there is a balancing equations assignment. Our next Zoom session, remember, is just to practice this. So I know I've given you 2 pretty intense worksheets, one on writing equations, one on balancing equations, but our next Zoom, no new information, just practice time and question time. Of course, you can also use my office hours if you have questions, but the whole purpose of our next Zoom is work time, breakout room time, question time, so that by the time you leave that Zoom, you feel like you know how to balance equations more than you do right now and writing equations more than you do right now. Thanks so much for listening as we continue to explore and understand more about chemistry. See you next time.